In this video, I'm going to talk to you about prime numbers, what makes a number a prime number, and then prime factorization, and also the preferred form of writing the prime factorization using exponents. Our English word prime is from the Latin root prim or primus, meaning first or first in importance. In 1570, Sir Henry Billingsley translated Euclid's Elements. That's a written work, an ancient Greek work, that called the numbers protos arithmos, or first numbers. Prime numbers are those numbers that have two factors only, 1 and itself. 1 is not a prime because it only has one factor. 2 is the only even prime number. Its factors are 1 and 2. 3 is prime, 1 times 3. 4 is not prime. It has three factors, 1, 2, and 4, because you can go 2 times 2, and that'll get you 4. Five is prime. Factors 1 and 5. 6, nope. It has 1, 2, 3, and 6. 7 is prime. 1 and 7. 8, nope. It has 1, 2, 4, and 8. 9, not prime. 1, 3, and 9. 10, no, it has 1, 2, 5, and 10. 11 is prime. 1 and 11 are the only factors. 12 is not a prime. It has 1, 2, 3, 4, 6, and 12. 13 is prime. It has 1 and 13 and no others. So if a number has only 1 in itself, we call it a prime number. If you can use any other number to multiply by itself or by another number to get the number, then that number is not a prime. Prime numbers have been thought about for a very long time. A bone was found in Central Africa that had groups of notches on it, 11, 13, 17, and 19, which are the prime numbers between 10 and 20. And there were other notches on the bone in groups that indicated mathematical thinking. You can look up the Ishango bone and read more about that if you would like to know more. In today's world, prime numbers are often used in cryptography. It helps keep our digital communications secure, meaning that you can have secret conversations about your money and not worry about it. Prime factoring. Prime factorization is finding all the prime numbers that can be used as factors for a given number. If you have a prime number like 2, the factoring is 1 times 2. It's a prime number. Only 1 and 2 are factors for 2. If you have the number 4, the factors are 1, 2, and 4. The prime factor, 2, can be multiplied by itself, so it has a 2 times 2 factorization. So these two 2's are all the prime numbers that can be used for number 4. If we have 8, we have 2 times 4. But that's not a prime, so that is 2 times 2 times 2, because the 2 times 2 is the same as 4. So 8 has 3 prime factors of 2. If you have 9, you have 3 times 3. Both 3's are primes, so that is the prime factorization of 9. If you have 12, you have 2 times 6. but 6 is not prime. So that would be 2 times 3. And 2 times 3 is the same as the 6. So your prime factorization of 12 is 2 times 2 times 3. If you have 15, you have 3 times 5. Both 3 and 5 are primes, so the prime factorization of 15 is 3 and 5. If you have 18, you have 2 times 9. 2 times 9, well, 9 is not a prime. As we see up here, it's 3 times 3. So we have 2 times 3 times 3. 2, 3, and 3 are the prime factorization of 18. So any number can be factorized into its prime. Say you had 21. 3 times 7. Well, both 3 and 7 are prime, so that is the prime factorization of 21. If you have 210, well, then you can have 3 times 7 times 10. But 10 is not prime. So 3 times 7 times 2 times 5. 10 is 2 times 5. 3 times 7 is the 21. 21 times 10, 210. My prime factorization of 210 is 3 times 7 times 2 times 5. And because math prefers to be kind of orderly, they prefer the final written form to start with the lowest prime and then work up the number line so that the proper or finished best form for the prime is 2 times 3 times 5 times 7, going from least to greatest prime factors in your final writing form of 210. Another math idea for helping with the prime factorization is exponents and exponent form in factoring. Exponents, also known as powers, is the way you write numbers for a repeated factor. You have a base number with a superscript number. If you have 2 times 2, you write it as 2 to the power of 2. That's the superscript. If you have 2 times 2 times 2, you would write 2 to the third power, superscript 3. The pattern is that you use the base number, then use the superscript number to tell you how many times the base number is multiplied. So 5 times 5 times 5 times 5 is written as 5 to the fourth. 12 times 12 times 12 is written as 12 to the third. 5 to the fourth would be a prime factorization. 12 to the third is a correct exponent, but not prime factorization, because 12 is not a prime. If I wanted to change 12 times 12 times 12 to a prime factorization, I would first change the 12s into primes. So I would take 12, which is 3 times 4, with the 4 being 2 times 2, and get 3 times 2 times 2. And then that would be times 3 times 2 times 2. Let's make these consistent here. Sorry about that. And another 3 times 2 times 2. Now, since I want to be mathematically tidy, I'm going to put all my 2's together and then all my 3's, because 2's are my least ones. 2 times 2 times 2 times 2 times 2 times 2 times 3 times 3 times 3. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 6 times factored, and 3 3 times factored. So my prime factorization of 12 times 12 times 12 is 2 to the 6 times 3 to the third. And that would be my final form for prime factorization of 12 times 12 times 12. Let's use the idea of exponents in prime factorization. You put all the factors in order that you find from least to greatest, check for repeated factors, and use the number of factors as an exponent. If you had 25, that would be 5 times 5. The only prime is 5, but it's used twice. 5 to the second power. 49, 7 times 7. 7 is the only prime, but it's used twice, so 7 to the second power. 125 would be 5 times 25, which is 5 times 5 times 5, because the 25 is 5 times 5. So our prime is 5 used 3 times to the power of 3. 105 is 5 times 21. 5 times 7 times 3. There are 3 primes in this factoring. Putting them in order of least to greatest would end up with 3 times 5 times 7. That's our preferred math order. 42 is 3 times 14. That is 3 times 2 times 7. Put it in math preferred order of primes, and it is 2 times 3 times 7. All of these factors are prime. Our best way to write it is least to greatest, 2 times 3 times 7. If you have a number like 625, that is 5 times 125. 5 times 5 times 25. 5 times 5 times 5 times 5. 5 to the fourth power. This is pretty powerful. It's not 5 times 4, because that's not very powerful. That's only 20. But 5 times 5 is 25 times 5 is 125 times 5. 5 to the fourth power will get you 625. If you have 525, well, it's divisible by 5, so 5 times 105. 5 times 5 times 21. 5 times 5 times 7 times 3. Then putting it in order of least to greatest, you have 5 times 5 to the second power, because there's 2 5s in it, times 7. So our preferred factorization form is 3 times 5 squared times 7. Powers make values go up very fast. In this video, I talked to you about primes, what is a prime, and prime factorization. And I talked to you about the preferred form for the prime factorization is in using exponents. I hope this made sense. In our next video about primes, we'll talk about how to use it to get greatest common factor and least common multiple and why those are helpful.